Okay, so now let's see some question. Let's say question is, what is the mass of 0.250 moles of, let's say, zinc? So first, what you have to do, using your data booklet, you can find the mass of zinc. So Zn mass is 65.38, right? That is a molar mass, so gram mole inverse. Now you can calculate, the mass can be calculated. How to calculate? Moles into molar mass, right? So moles is given in question 0.250, multiply with 65.38, which will come around 16.3 gram. Right? In this way you can calculate. One question will be there like this. Let me practice one more question. The question says, how many moles in 2.64 gram of sucrose, and the mass of sucrose is given in the question 342.3. How to do? Simple. So the molar mass is given. Molar mass is given in the question is 342.3 gram mole. Now we have to find the number of moles. How to find? By mass divided by, if I am going to divide mass divided by molar mass, we will get moles, which is 2.64 divided by 342.3, we will get around 7.7 into 10 to the power minus 3 moles. So always show you working in calculation, as it becomes easier to check for error, and you may pick up credit if you get a final answer wrong, right? Because you get marks for the calculations, so that's important. Let's go to the empirical formula. Fine. So the molecular formula, we know the molecular formula, right? What is the molecular formula? So molecular formula is the formula that shows how many number of atoms are present, right? We can say that the molecular formula is the formula that shows the number, and it also gives type, number and type of each atom in a molecule. Let's say example, if I am saying ethanoic acid C2H4O2, this is ethanoic acid. So we can count the number, how carbon is 2, hydrogen is 4, oxygen is 2, and we can also tell the type. So there is 1. So we are getting number, and we are also getting type of atom. But empirical formula is the simplest one. What is the empirical formula? Empirical formula will give you just the type, not the number. Empirical formula is the simplest whole number. Fine. Simplest whole number ratio of each element present in one molecule or formula unit of compound, right? Like in this example, it's written C2H4O2. So the empirical formula will be, you can see it is simply divisible. So 2 ones are 2, 2 twos are 4, and then 2 ones are 2. So can I write C1H2O1, or you can say CH2O. This is also correct. So the empirical formula actually detects what we can get it from there. So you can get percentage composition by mass of the element. That's a one benefit we can get. So organic molecules often have a different empirical as well as molecular formula. This is important. Generally, organic molecules often have different empirical and molecular formula. And if you will see in the ionic compound, the formula of an ionic compound always in empirical. Just for a safer side, you just understand the formula of an ionic compound is always an empirical formula. You just remember. Okay? Let's discuss few examples, how and what kind of questions you are going to get from the empirical section. So let's say I am putting a question. Question is, determine the empirical formula of a compound that contain 10 gram of hydrogen and 80 gram of, let's say, oxygen. How to do that? So first, you can write mass of element. Let me write for hydrogen and for oxygen. So mass of the oxygen given in the question is 10 gram. This is 80 gram. Right? How many moles are there? So what you have to do? You have to divide masses by atomic mass. So here we are going to get 10 divided by 1.01. Here 80 divided by 16.01. Here we will get 10 moles. Here we will get 5 moles. Right? So now we have to divide with the simplest. So between 5 and 10, 5 is the least. So now divide by lowest figure. So lowest figure is 5. So we'll write 10 divided by 5 and 5 divided by 5. Here we will get 2. Here we will get 1. So the empirical formula is H2O. Right? Let's practice one more question. question is find empirical formula of a compound that contain, let's say, 85.7% carbon and 14.3% hydrogen. So here also you have to solve it like that. So note that these percentage which is given can be considered as a mass, right? So mass for carbon and hydrogen, carbon is 85.7, this is 14.3, right? So this we have got mass. Then divide this value 85.7 or 14.3 by molar mass, divide by atomic mass. That means 85.7 divided by 12.01, and here 14.3 divided by 1.01. Here we are going to get 7.14 mole. Here we are going to get 14.2 mole, right? Now simplest value 7.14, this is simplest, so we can write 7.14 divided by 7.14, 14.2 divided by 7.14. Here we will get 1, here we will get 2. So the empirical formula is CH2. This is the answer. That's it. See you in the next video.